Hi, Mr. Long here for another screencast on the fundamental theorem. And this one we're going to look at is, it looks at first that it's quite blank. We really don't have much information at all. But we have a fair bit, actually. We have a fair bit. And you know, I can get quite a lot out of this. So the first thing we want to do is, what does this tell me? Okay, what does that tell me? And I know that f at, or whoops a daisy, the integral from 3 to 8 of f at x dx equals, that's the area for of the rate curve, and that has to equal the change in y value on the original function between 8 and 3, right? Because I'm going left to right from 3 to 8. So if I look at this, then this right here is, again, delta, which means change in y value on the original. So, so what I'm going to do here is try and understand what's happening. So I know that this number has to be 3, and I know that the change from 3, from x equals 3 to x equals 8 is plus 12. This is a positive area, right? If the area is positive, what's true about the rate? So the area under the rate graph is positive. Positive area would, and again, go back to the snowfall, snow melt. That means snow is falling. That means the snow is getting deeper and deeper and deeper. Okay. Now, this might not be a snowfall example. And in this case, you're going to see it, you know, you're going to go, Mr. Long, it can't be a snowfall graph. And you're right, it can't, but it could be a different rate graph or a different original function. So I know that it increased by 2. Now, I've got an equation down here I could simply solve, right? I know what f at 8 is. I know what this is. That's worth 12. So then I could solve for f at 3, okay, in this formula. So f at 3, I'm going to add it to both sides, and I'm going to subtract that on both sides. So I'll end up with f at 3 equals, well, you know what, I'll make this, D, E, and F. So if D equals E minus F, F has to equal E minus D. Okay, E minus D. So that's going to be, E minus D is 2 minus 12. So that's going to be negative 10. Now, does that make sense? Yes, it sure does, because look at this. I had to add 12. The area was positive. Okay, so I started at negative 10 in the original, and I went all the way up to a y value of 2. The change in y value in the original is the area under the rate curve. Okay, so we know that. What can I draw about the graphs? Let's see. So I go, the x values I've got are 3 and 8. And what do I know about those? I know the y values on the original. So I know that at x equals 3, the y value was negative 10. I know that at x equals 8, the y value was 2. So that means I go from there to there, right? Do I know what the curve looks like? No. But I do know that the curve is increasing. Okay, the curve is increasing. The curve could be decreasing at points too, but the overall area is 12. Okay, what can I draw on the rate graph then? Well, let's see here. Can I draw very much? I just know that overall the total area between 3 and 8 is 12. So there's 3, there's 8. So it could be something like this, right? That area is positive 12. Now, there could be another scenario though too, many other scenarios. It could be this as well. And this is the part that makes this question kind of challenging. It could be something like this as well. It could be, I could start here, right, and go to like that, in which case this would have to be, this area here would be, say, negative 2, and then this area here would have to be 14, right? Because 14 plus negative 2 is 12. So any combination of areas in there that adds up to positive 12. So again, there are many, many possibilities. Really, what would I expect on a test? That one. If you want to get more complex, you can, but you don't have to. Okay, so that's one where there's a lot of open-endedness to it. And I think you can imagine how that would affect this graph, because this graph here, if I was to sketch it as well, I'm going from negative 10 up to 2, from 3 to 8, but can I do that by, say, could have I been at negative 10 there and started to drop right away and then gone up to 2, right? I could have done that, okay? So there's a variety of ways we draw it, but the main thing is that it starts at negative 10 at x equals 3 and it finishes at x equals 8, its y is 2, right? So whether it just goes up the whole time or whether it dips and then goes up, we don't know, okay? We don't know. But I think you can see where that's that negative area there. You can see that this rate graph would correspond to this original function. This rate graph would correspond to this original function. Okay, folks? So again, watch it again, then start doing some more questions. All right? Good luck.